Hello everyone. Today is discuss about BSc first year mechanics of a particle, that is paper name semester 1. This is today is discuss about the mechanics of a particle in subtopics, that is angular moment, conservation of angular momentum, relation between torque and angular momentum, symmetric top and precisional motion. These are today discuss about these topics. Okay, what is angular momentum? Angular momentum is defined as consider a particle of mass m and linear momentum p at a position r. Position vector is the r with respect to the origin and inertial reference frame as shown in this figure. This is the axis and that is O is the center of center, and this is, let us consider one particle is p. This is the particle mass is m and that is position vector is particle and origin, that is the distance between position vector r bar. So angle r and position vector and angular momentum is angular between theta is the angle, angle between theta. So that is angular momentum, linear momentum, that is the acting on the particle p which is a rotation about origin. So that is it. What is the angular momentum? That is the symbol of angular momentum is L. L is equal to r cross p bar. That is the angular momentum of L is the particle with respect to the origin. O is defined as the product of the position vector and particle p. Angular momentum is a vector. So the angular momentum is, its magnitude is given by the L is equal to r cross p is equal to r dot p sin theta. Here position vector and particle is angle between theta. So that is L is equal to r dot p sin theta. Theta is the angle between the position vector and particle. The direction of L is normal to the plane containing position vector and particle. So conservation of angular momentum. So this the law of conservation of angular momentum of states that if no external torque acts on a body rotating about a fixed point, the angular momentum of the body is remains constant. Angular momentum is the position vector and particle p, that is the product of the r and p. Now L is equal to r cross p. So you can write a number of particles, that is p1 p2, that is let us consider that is pi. So that is the position vector. One particle is distance o and that is the o, and p is the distance is the position vector r1, and another particle, that is the origin to second particle distance is the position vector r2, that is up to number of distance between the r1, r2, r3, you can write ri. So angular momentum L is equal to r cross p. So L is equal to summation of I equal to 1 to n, that is ri cross pi. The rate of change of the angular momentum is equal to, you can, this is the angular momentum, the rate of change of angular momentum is given by dl by dt is equal to d by dt ri cross pi. So this is differentiating with respect to t. So I can dl by dt is equal to ri cross dpi by dt. So from applying the Newton's second law, so Newton's second law is equal to, that is force is equal to mass into acceleration. So external force is equal to dpi by dt. So the rate of change of the linear momentum, that is external force is equal to dpi by dt. So external force, if external force is equal to 0, then dpi by dt is also 0. So then external force, then value is substituting in equation 2. So dpi by dt means external force, you can write dl by dt is equal to ri cross f external force. So therefore dl by dt is equal to external torque. So you can, you know, that is torque is equal to r cross f external force. Dl by dt is equal to external torque. So if torque external torque is equal to 0, then that is angular momentum, the rate of change of the angular momentum dl by dt is also 0. So you can write L is equal to constant value. So this value is the rotation of axis of rotation of motion. If no external torque acting on a system of a particle, the angular momentum remains constant. This law is conservation of angular momentum. Angular momentum, conservation of angular momentum is L is equal to constant. And again angular momentum is the L is equal to R cross P is the formula. Then conservation of angular momentum L is equal to constant. And relation between torque and angular momentum, you know, torque is equal to R cross F and angular momentum P is equal to R cross P. This is L is equal to R cross P and torque is equal to R cross F. The relation between torque and angular momentum can be derived as this following. The force acting on a particle is given, F is equal to the rate of change of the angular momentum, that is taking vector product of R on both sides of applying. Then we have R cross F is equal to R cross into dpi by dt, taking vector product in both sides. So that is R cross F is equal to R cross dp by dt. So since R cross F is, that is torque, you know, and then substitute the value in R cross F is equal to torque. Torque is equal to R cross dp by dt. So angular momentum, what is the angular momentum? The product of position vector and particle, that is L is equal to R cross P. So now applying the L is equal to R cross P, that is torque is equal to R cross dp by dt. So L angular momentum L is equal to R cross P, then differentiating in with respect to T in angular momentum equation. So dl by dt is equal to d by dt into R cross P. So he can then this is differentiating with respect to T UV method, that is one is constant and another one is differentiating, and second one is constant and another one is differentiating. So that's why R is constant, that is cross of dp by dt plus, and again dr by dt, and P is also constant. Dr by dt is equal to V, and that is velocity is equal to distance by time. So here that is the O and P is the distance of position vector R, that is dr by dt is equal to V, and linear momentum, that is mass into velocity. So P is equal to mv, with you can write this equation in the above equation. Dl by dt is equal to R cross dp by dt plus what is dr by dt is, you can write V, and cross P is equal to mv. So dl by dt is equal to R cross dp by dt plus V cross mv. So this value is the vector cross product, that is equal to 0. So this term is equal to 0, that is because vector product of two parallel vector is 0. So that's why you can write V cross mv is equal to 0. Dl by similarly dl by dt is equal to R cross dp by dt. This value is substituting in equation 2. What is the second equation? Torque is equal to R cross dp by dt. We can write this value in equation 5. dl by dt is equal to R cross dp by dt means torque. This is the equation of torque and angular momentum relation between this equation. So angular momentum and torque relation is torque is equal to dl by dt. Okay, the rate of change of the angular momentum of a particle is equal to the torque acting on it. This is the proof of the torque and L. And next, symmetric top and precessional motion. So a symmetrical body rotating about an axis which is fixed at one pointing is called the top. A symmetrical body rotating about an axis which is fixed at one pointing is called the top. Okay, this as shown this figure. Okay, the spinning about its axis of symmetric with angular velocity is the omega. In rotation of the axis of rotation of the spinning top, it is called the precession. Then axis paranga rotate అయినట్లయితే దాన్ని axis of rotation గా find out చేసుకోవడం జరుగుతుంది. So the action about this axis about the rotation of this spinning top, that is called the axis of precession. ఓకే. సో దిస్ ఈస్ టాప్ ఈస్ దెన్ యాక్సెస్ ఓజెడ్ యాక్సెస్ పరంగా రొటేట్ అవుతూ ఉంటుంది. దట్ ఈస్ ద యాంగులర్ వెలాసిటీ ఈస్ ద ఒమేగా. అండ్ దెన్ ఆఫ్టర్ దట్ after seconds then this top is fall down on the earth. Then angular velocity is the omega and L is the angular momentum. So that is the then the center of the mass is C, then origin is O, that is OC is equal to r bar, that is the position vector. So C is the center of the mass, then force is some force is applying, that is F is equal to mg. So then this forces are acting on this top. One is the reaction force acting towards upward at a center, that is origin O. Okay, first force is reaction force acting upward at center O. The second one is the weight of the top, that is F is equal to mg. So the weight of the top acts downwards at the center of the mass. So torque acting on the top due to weight, that is due to weight of the top is, that is torque is equal to r cross F, that is torque is equal to r cross F. What is the F is equal to mg, weight, that is this is r and this is the force F, that is the angle between theta. So he can write torque is equal to r cross mg sin theta. It is the angular momentum, that is relation between the angular momentum and torque, that is torque is equal to del L by del T. So you can write del L is equal to torque into del T. So this is the precessional angular velocity is the omega p. Within time t time, then angular momentum is the L. Then after del t seconds, the angular momentum is L plus del L. So you can that is angle of del pi. So here this is the L. Within after del t seconds, then angular momentum is del L. So you can write that is del L. So he can, after that del t seconds, the angular momentum is L plus del L. Here that is precessional angular velocity, that is precessional angular velocity in OZ axis is rotation of this axis of precision, that is omega p is equal to del pi by del T. Del pi is equal to BC from figure, that is BC by AC. So here BC is the del L and AC, you can find out the AC value, then angle of theta. So theta, sin theta is equal to AC by OC. So AC is equal to OC sin theta. You can write AC is equal to OC sin theta value. Then del pi is equal to BC by AC. Then you can write del L by OC sin theta from figure is equal to del L by L sin theta. So OC is the, that is angular momentum, that is L sin theta. Precessional velocity omega p is equal to that is torque by L sin theta. Here omega p is equal to torque is equal to mg r sin theta by L sin theta. Here sin theta is both are cancelled, that is precessional velocity omega p is equal to mg r by L. You can write L is equal to I omega. So that is precessional velocity omega p is equal to mg r by I omega. This is the precessional velocity. So and this is the symmetric top and precessional motion. Precessional velocity omega p is equal to mg by L. Precessional velocity is proportional to the position vector and precessional velocity is the inversely proportional to the angular momentum. So and that is precessional velocity is the then rotating the OZ axis. You know everyone, then symmetric top is using in with play with in childhood days. మనం ప్రిసిషనల్ టాప్ అనేది చిన్నగా ఉన్నప్పుడు యూజ్ చేసుకున్నాం, దట్ ఈస్ ద బొంగరం అంటాము. బొంగరమాన్ని మనము రొటేట్ దాని మీద కొంత ఫోర్స్ అప్లై చేసుకున్నట్లయితే అది ఒక యాక్సెస్ పరంగా రొటేట్ అవుతుంది. సో సమ్ టైం తర్వాత ఆఫ్టర్ కొన్ని సెకండ్స్ తర్వాత బొంగరం అనేది ఆ టాప్ అనేది ఎలా ఉంటుంది, ఫాల్ డౌన్ ఇన్ ద ఎర్త్. సో ఆ టైంలో దట్ ఈస్ ద విత్ ఇన్ సెకండ్స్ దెన్ ఎండ్ ఆఫ్ దిస్ యాక్సిలరీ రొటేషన్స్. సో within the angular momentum is the L and center of the mass is that is C అండ్ దట్ ఈస్ ఆరిజిన్ విత్ ఇన్ మన అక్కడ ఆరిజిన్ పాయింట్లోనే రొటేట్ అవుతూ ఫాల్ డౌన్ అవుతుంది. సో అప్పుడు దాని యొక్క సెంటర్ ఆఫ్ పాయింట్ ఈస్ ద సి, దట్ ఈస్ సెంటర్ ఆఫ్ మాస్ ఈజ్ సి అండ్ పొజిషన్ వెక్టార్ ఈస్ ద ఆర్ విత్ రెస్పెక్ట్ టు ద ఓ పాయింట్. దెన్ ఫోర్స్ ఈజ్ ఈక్వల్, వాట్ ఈస్ ద ఫోర్స్? ఫోర్స్ ఈజ్ ద mg value. So here apply to torque also. So then torque and acceleration, that is torque is equal to r cross f. సో వాట్ ఈస్ ద ఫోర్స్? ఎఫ్ ఈజ్ ఈక్వల్ టు ఏంటి? ఎంజీ అనేది మరియు దట్ ఈస్ ఇక్కడ పొజిషన్ వెక్టార్ అనేది దట్ ఈస్ అక్కడ సెంటర్ ఆఫ్ పాయింట్ అనేది. సో దట్ ఈస్ ద యాంగులర్ బిట్వీన్ theta. So you can write torque is equal to r cross mg sin theta. So angular momentum is the rate of change of the angular momentum is equal to the torque. Torque is equal del L by del T. That relation between torque and L also, del L is equal to torque into del T. And this is axis within OZ axis పరంగా మనకి టాప్ అనేది రొటేట్ అవుతుంది. దట్ ఈస్ ద యాక్సెస్ ఆఫ్ ప్రిసిషన్ అని అంట. ఈ యాక్సెస్ ఆఫ్ ప్రిసిషన్ పరంగా రొటేట్ అవుతున్నప్పుడు దెన్ విత్ ఇన్ టీ అనే టైంలో యాంగులర్ మూమెంటమ్ ఈస్ ద ఎల్ అండ్ ఆఫ్టర్ డెల్ టీ సెకండ్స్ దెన్ ద యాంగులర్ మూమెంటమ్ ఈస్ del L. So you can angle of del phi. So that is within del t after seconds the angular momentum అనేది చేంజ్ అవుతుంది. L అనేది L plus del t గా చేంజ్ అవ్వడం జరుగుతుంది. సో here angle then you can write this is the axis of OZ axis పరంగా precisional angular velocity is the omega p. Then BC, then you can draw these lines and BC is the distance of del L and AC here you can, that is BC is equal to del L and angle of sin theta is equal to AC by AC sin theta is equal to AC by that is OC. This is sin theta is equal to AC by OC. AC is equal to OC sin theta. Here OC is the L. So I can write del L by L sin theta. Then simplification of this precisional velocity omega p is equal to mg r by L, proportional to the inversely proportional to the angular momentum and precisional velocity is proportional to the position vector depending on this precisional velocity omega p. This is the symmetric top and precisional motion. And once again I can repeat then relation between torque and angular momentum. The relation between torque and angular momentum can be derived as follows. The force acting on a particle is given by F is equal to the rate of change of the momentum, that is dp by dt. So F is equal to the taking vector product of r on the both sides of this equation. So then cross multiplication in both sides of r position vector, this is r cross into F is equal to r cross dp by dt. You can write torque is equal to r cross F. So then torque value is substituting in the above equation, torque is equal to r cross dp by dt. So angular momentum L is equal to r cross p, differentiating with respect to the angular momentum with respect to t. So dl by dt is equal d by dt r cross p, r cross into dp by dt plus dr by dt. This is here r is constant with respect to and p is the differentiating dp by dt plus and r is the differentiating, p is the constant, dr by dt cross p. So dr by dt is equal to v and p is equal to mv. You can write these values in the above equation. dl by dt is equal to r cross dp by dt plus v cross mv. So here dr by dt is the v, p is equal to mv. So then this is the two vector products. So that is v cross mv is equal to 0. This is the in this term is that is equal to 0. Vector product of two parallel vectors is 0. So that's why v cross mv is equal to 0. So I can write dl by dt is equal to r cross dp by dt. So r cross dp by dt means that is torque from equation 2. Torque is equal to r cross dp by dt. So dl by dt is equal to torque. This equation is the relation between torque and angular momentum. So torque is equal to dl by dt. The rate of change of the angular momentum of a particle is equal to the torque acting on it. This is torque is equal to dl by dt. Okay, this is the relation between torque and angular momentum. And similarly, conservation of angular momentum. So you know, conservation of linear momentum, that is p is equal to constant, and conservation of angular momentum is equal to constant. That is the law of the conservation of angular momentum. That is, if no external torque acts on a body rotating about a fixed point, the angular momentum of the body remains constant. So you know, angular linear momentum angular momentum L is equal to r cross p. So within number of particles, that is p1, p2, p3, you can write, that is the origin to particle, that is the distance of position vector r bar. So that is first particle, then p1, and origin, that is the distance of position vector is r1, and second one particle p2, that is the position vector r2 with respect to O. So we can write number of particles, summation of I equal to 1 to n ri cross pi. The rate of change of the angular momentum is given by dl by dt is equal to d by dt ri cross pi. So that is dl by dt ri cross dpi by dt. From Newton's second law, is F is equal to mass into acceleration. So external force is equal to the rate of change of the linear momentum. So dpi by dt. So no external force, then dpi by dt is also 0. So external force is equal to 0, then dpi by dt equal to 0. This value is substituting in the above equation. dl by dt is equal to Ra cross dpi by dt means external force, you can write. So what is the torque? Torque is equal to r cross external force, r cross f. So you can write this value is torque. dl by dt is equal to external torque. If external torque is equal to 0, then dl by dt is equal to 0. So angular momentum is equal to constant. The rate of change of the angular momentum is equal to 0, then the value of angular momentum is remains constant. This law of the conservation of angular momentum. Okay, so that is angular momentum. Conclusion of this topics: angular momentum L is equal to r cross p, and conservation of angular momentum, that is L is equal to constant, and torque and angular momentum relation between torque is equal to dl by dt. This is the rate of change of the angular momentum of a particle is equal to the torque act on it. That is the relation between the torque and angular momentum. And symmetric top and precessional motion. So a symmetrical body rotating about an axis which is a fixed at one pointing is called the top. Then axis paranga rotate అయినట్లయితే దాన్ని axis of precision అని చెప్పడం జరుగుతుంది. సో దెన్ rotate, that is torque అనేది torque is equal to r cross mg sin theta, and relation between L and torque is equal to, then simplification, torque is equal to del L by del T, then simplify of this precisional velocity omega p is equal to mg r by L. So L is the, you can write I, omega is also. So that is precisional velocity is equal to mg r by L. This is precisional velocity is depending on proportional to the position vector and proportional to the force and inversely proportional to the angular momentum. You know, torque is the torque acting on the rate of change of the angular momentum, that is torque is equal to dl by dt, you know. Then proof is torque is equal to I alpha also. So you can write torque is equal to dl by dt. L is means, that is L is equal to r cross p. You can substitute this value. Then similarly external torque is equal to 0, that is dl by dt is equal to ri cross external force. So then you can write torque is equal to r cross F, then dl by dt is equal to external torque. If let consider external torque is equal to 0, then dl by dt is equal to 0. So that the rate of change of the angular momentum is equal to 0. So that is, then remaining the angular momentum remains L is equal to constant. This is the conservation of angular momentum and conservation of angular momentum and angular momentum. So you can once again I can explain angular momentum L is equal to r cross P. So the position vector and a particle, that is the product of the position vector and particle is equal to the angular momentum. L is equal to r cross P. Conservation of angular momentum means, that is this is conservation of angular momentum is dl by dl, that is dl by dt is equal to 0. So the rate of change of the angular momentum is equal to 0, that is the angular momentum is remains constant. So that is the conservation of angular momentum. And relation between torque and angular momentum is equal, torque is equal to dl by dt. The rate of change of the angular momentum is equal to the torque. So torque is equal to dl by dt. And symmetric top, that is the precessional motion. So precessional motion omega p is equal to that is mgr by L. So that is mg is the force and r is the position vector and L is the angular momentum. So symmetric precessional velocity is proportional to the force and precessional velocity is inversely proportional to the angular velocity, and precessional velocity is proportional to the force.